Hey guys, today we're going to look at word problems that involve geometry. So in order to be able to work on these, we have to know some basic geometric concepts. We're going to start with supplementary and complementary angles. Supplementary angles are two angles that add up to 180 degrees. Two angles that add up to 180 degrees, whose sum is 180 degrees. What they look like, so you can get a visual, is they look like a straight line. So if this was angle A and this was angle B, together they add up to 180. So when you don't know both of the angles, you might call one of them the angle, and you might call the other one its supplement. Its supplement meaning that together they make the 180 degrees. Complementary angles, same idea, except that they add up to 90 degrees. Okay, two angles whose sum is 90 degrees. So what that looks like is a right angle. And again, if I had split it into two sections, A and B, if A is the angle, then you would call B its complement. Okay, so we use these terms in these word problems where you don't know both of the angles. For example, in example 1, the measure of an angle is 15 less than twice its complement. So I'm going to call its complement x. Let x equal the complement. And it says the measure of an angle is 15 less than twice its complement. So 2x minus 15 would be the angle. And you know that if one of the angles was the complement, then together they are complementary, they add up to 90 degrees. So x plus 2x minus 15 has a sum of 90. And you would solve and then substitute back in. So you would get 3x minus 15 equals 90, 3x equals 105, divide both sides by 3, you're going to get 35. And then you plug it back in, the complement is 35 degrees. The angle is 70 minus 15, which is going to be 55 degrees. Okay. Another version would be what you see in example 2. One angle exceeds 3 times its supplement by 20 degrees. So I might call the supplement x. Oops, sorry, wrong pen. Okay, I might call the supplement x. And then one angle exceeds 3 times the supplement by 20. So 3x plus 20 is the angle. Together, they're supplementary. Together, they add up to 180 degrees. So I'm going to set up 3x plus 20 plus x equals 180. Okay, I'm going to skip the steps where I solve and sub back in. I think you guys understand that part. It's really more about setting it up. Okay, the next geometric concept we're going to go over is the angle sum theorem. The angle sum theorem, the triangle sum theorem, excuse me. The triangle sum theorem says that for any triangle, okay, for any triangle, the sum of the angles, of the interior angles, meaning the angles inside the triangle, is 180 degrees. So you'll see different variations of these problems. For example, in example 3, the angles of a triangle are consecutive integers. Find the angles. Well, consecutive integers increase by 1. They go x, x plus 1, x plus 2. And so since it's a triangle, you're going to have 3 angles. So you could let x be the first angle, the second angle could be x plus 1, and the third angle would be x plus 2. And you know that the sum of the angles of any triangle is 180 degrees. So you set up an equation that says x plus 1 plus x plus 2 equals 180 degrees. And then you solve and substitute. I'm going to skip that part again just to speed things along and not get too boring. I think it's more about how do we set these things up. Example 4, another version of this. This one doesn't involve consecutive integers. This involves comparison. So it says one angle of a triangle is 35 degrees less than the measure of the second angle, and the third angle measures 10 degrees less than the first angle. So you could let x be maybe like the second angle. And then one angle is 35 degrees less than the measure of the second angle. So x minus 35 would be the first angle. And then the third angle measures 10 degrees less than the first angle. So 10 degrees less than the first angle would be x minus 35 minus 10, which is really x minus 45 would be the third angle. And once you have the let statement set up, then you say, well, it's a triangle, so the sum of the angles must be 180 degrees. So you say x plus x minus 35 plus x minus 45 is equal to 180 degrees. And again, solve from there and substitute back into your let statements to get the three angles. Here's another version that you might see related to to triangles and the interior angles of a triangle. The angles of a triangle are in the ratio of 2 to 3 to 4. Now, we did this kind of a setup with ratios earlier in the school year in our do-nows. Whenever you're given a ratio like this, you're basically just going to set up let statements that go like this. 2x is going to be the first angle, 3x will be the second angle, and 4x will be the third angle. And the reason is that this ratio has been reduced from some higher ratio. That means that every one of these numbers was multiplied by the same number, so we call it x. So you just multiply each of them by x, and those are your let statements. And since it's a triangle, the sum of the angles is 180 degrees. So 2x plus 3x plus 4x equals 180. And again, you solve and then sub back into your let statements. Okay, the last concept we're going to look at is the isosceles triangle. If you remember from last year, an isosceles triangle has two congruent sides. These sides are called legs. So you have a leg, and then the side that measures different from the other two is called the base. And then it also has two congruent angles. This angle and this angle measure the same amount. These are called base angles. Base angle, another base angle. And then it has this angle up here that measures a different amount than the other two angles, and this is called the vertex angle. So for example, you might see a triangle, an isosceles triangle that looks like this, that measures maybe 20 degrees here, 20 degrees here, and then this would have to be, since these add up to 40, this would have to be 140 degrees. So 140 degrees is the vertex angle, and 20 degrees is each of the base angles. So you would say each base angle equals 20 degrees, and the vertex angle equals 140 degrees. And then if you look at the lengths of the sides, right, the sides are different from the angles. This side might measure like, I don't know, 10 centimeters. And then this side would have to be congruent to it. It would also be 10 centimeters. Those are called the legs. And then the base would measure a different amount. So maybe this one measures like 40 centimeters. And so that's when you talk about perimeter. The perimeter of the triangle would be 60, because 40 plus 10 is 60. That's different from the angles. So you might see questions based on the sides, in which case you'd be given perimeter, and you might see questions based on their angles, in which case the angles have to add up to 180 degrees, but you always know that you have two congruent angles, one that's different called the vertex, and two congruent sides, one that's different called the base. So we have, in example 4, they talk about the angles. The vertex angle of an isosceles triangle is 20 less than twice the measure of each base angle. So what I would do is I would draw a diagram of an isosceles triangle. Everything's being compared to each base angle, so I would call that x. That means this base angle is x and this base angle is x. We're talking about angles, not sides. The vertex angle, meaning the one that's different, is 20 degrees less than twice the measure of those. So 2 times x minus 20. We know the sum of the angles of any triangle is 180 degrees. So you add all the angles, x plus 2x minus 20, and set it equal to 180 degrees. Solve, substitute. Okay, and finally, the next one is about isosceles triangle also, but this one talks about perimeter. So when you talk about perimeter, you're looking instead at the sides, not the angles. So the perimeter, so now when we look at this, I'm going to put my measurements on the sides, like in the middle of the lines. The perimeter is 70. If the base measures 10 centimeters longer than each of the legs, so I'm going to let each of the legs be x, and the base is 10 centimeters longer than each of them, so x plus 10. When they say each, they only mean one of them at a time. And now, again, these are sides. I'm going to add them up to the perimeter. Perimeter is 70, so x plus x plus x plus 10 is equal to 70. And that is my equation that I set up and solve and substitute. Okay, so we will go over this in class also during Zoom today. Okay, thanks.